Welcome to our video on square roots and cube roots. This will be kind of a short one for us because there's not a lot of stuff in here. It's just an extension off of the power stuff that we've been doing. A couple terms to go through real quick. One would be radical. It's more of a symbol of square rooting or cube rooting. This is the symbol that you're going to see. It has a little shelf on it, and sometimes you see a little back end of it closed in. An example of two that look or mean the same thing is one like this, and then you have one like this with the little 2 on the top or on that little shelf there. That will indicate that we have a square root. So we're looking for what is the square root of that number, and we'll talk about what that means in a minute. The other one that you're going to work with is one that has the 3 on the little shelf, and this is dealing with cube roots. So when we talk about roots, most people get it confused with division. It's not division. We're not dividing at all. We're kind of doing the opposite of squaring and cubing of the number. So when we went through and did our squares and cubes, now we're going to kind of go in the opposite direction. So the question that you got to ask yourself is, what number times itself? Or in the case of something that's cubed, it's what number times itself 3 times. So through the examples, you'll get an idea of what that is standing for. So our first examples are going to be perfect squares. Now for this one, you can use this to finish your chart. We're going to kind of start small in this, and we're going to talk about if we are given the square root of 4, we're looking for the same number that's multiplied to itself just twice. So one here, one here. So in this case, the square root of 4, we would look at 2 times 2 would give us the 4, but we're looking for the root of the number, so that means that just 2 is the root. So it kind of goes in a circle of what we talk about on the chart. We started with the powers, taking 2 squared, getting 4. Now we're going to take the root of the 4 and go back to getting to that squared part. So if we look at the square root of 16, our root is going to be 4. Meaning, if I take 4 squared, I'm going to get the number 16, which is what I'm looking for here. So again, there's that circle for this. Square root of 36 would end up being 6. Or you can think of it as 6 squared or 6 times 6. Square root of 121 would give you 11. A couple more. Square root of 9 is going to be 3, so that's the root. And square root of 25, the root of that is 5. So these are your perfect squares. They come out to whole numbers. There's no decimals or what we would consider irrational numbers in our real numbers section. For our second part, perfect cubes. Again, this is the other side of the chart, last column on this. So we're looking now for what is the same number times itself 3 times, because it has the cubed or the 3 up there. So we're looking for the cubed root of 27, which we would think of 3 times 3 times 3. So the root of this answer would be 3. So the root of the cube root of 27 is 3. Same as if we ask for the cube root of 64, we're looking at 4 as the root, meaning if I take 4 cubed, it gives me 64. For the other examples, if I have the cube root of 125, we're looking for 5 as being the root. So we think of it as 5 cubed or 5 times 5 times 5. Cube root of 1,000 comes out to be 10. Cube root of 343 comes out to be 7. Cube root of 729 is 9. So again, if I take 7 and cube it, I get 343. And again, we're looking at kind of a pattern that goes back and forth in your chart that we're working on. The last section that we're going to talk about is we're going to give you what we call expressions. Expressions are when we throw letters at you. We call them algebraic expressions because they're letters. We're going to give you those values for the letters for this part. Later on, we're going to solve for a variable or a letter. So when we have these terms in here, we're given the square root or the cube root or whatever the y stands for. In this case, it's 2. So we look at it's the square root of 9. That's going to give us 3. We have our x our x stands for 4, and anytime that I have a base or a whole number in regards to taking it for that, I'm going to use parentheses. So I'm going to put this in parentheses, and it's very important that you use them. Our y up here was the power of 2, so we're going to take 4 and square it. So we're just making a simple order of operation problem where we have the square root of 9 is 3, 4 squared is 16. Add those two together, we end up with 19. So if we look at this expression over here, we have a y. We say that the y is equal to 3. And so we put in the 3 for the y. So it's the cube root of 27, which gives us 3. We have 6 to the x power, x being 2. So we're going to put the 2 in for x. 6 squared gives us 36. And again, we combine them at the end to give us 39. For the bottom one here on the left, we have again the radical sign with the variable outside. That's going to be x, so we're taking the square root of 25, so the root of that is 5. We have a y, but in this case y is a negative 4, and this is why it's important that you use parentheses, because if you do not use parentheses and you square this number due to the fact that that means 2, this changes your whole problem, because the parentheses now group everything where this negative is now affected by the power. So it would be a negative 4 times a negative 4, which is negative 4 squared, which gives us a negative base to an even power, which means that we get a positive answer. So we have 5 plus 16. That gives us an answer of 21. Our last example, doesn't matter how many terms that you've got in here, take them step by step as you go. So we have x to the y plus the z root of 343 minus 4. So the 4 we're just going to bring down as long as we go. In our second step, we're going to introduce our letters, what their numbers actually are. And again, when I put my base in, I'm going to use parentheses. So my x is 7, my y is 2, and my z is 3. So wherever I see these letters in my problem, those are the numbers that are going to represent the letters. So I have 7 squared. I have now the cube root of 343, and that's all minus 4. So I get 7 squared gives me 49. The cube root of 343 is 7. Bring down my 4. Take care of my order of operations going left to right. So I have 49 plus 7 minus 4. 56 minus 4 gives me a total of 52. So again, algebraic expressions, introducing the number for the letter shouldn't be too difficult once you understand the idea of what we're trying to get across to you. So as you go through this, try and fill out your chart, get that done, both the square and the cubes, because you're going to use it in this section.